Avogadro's hypothesis states that equal volumes of gases at the same temperature and pressure contain the same number of molecules. In other words, if you have two containers of gas that are at the same temperature and pressure, and they have the same volume, they will contain the same number of molecules. This hypothesis is also known as Avogadro's law. Avogadro's law is a gas law that states that at a constant temperature and pressure, the volume of a gas is directly proportional to the number of molecules or atoms present in the gas. This law is named after Amedeo Avogadro, an Italian scientist who first proposed it in 1811 mathematically. Avogadro's law can be expressed as V equals K times N, where V is the volume of the gas, N is the number of gas molecules or atoms, and K is a proportionality constant. This law is only valid for ideal gases, which are gases that behave according to certain idealized assumptions, such as having no intermolecular forces and occupying no volume themselves. Avogadro's law is important in many areas of science and engineering, including chemistry, physics, and materials science. It is often used in calculations involving the behavior of gases, such as determining the molar volume of a gas or the number of moles of a gas in a given volume. Applications of Avogadro's hypothesis. The applications of Avogadro's hypothesis are numerous and include stoichiometry. Avogadro's hypothesis is used to calculate the stoichiometry of chemical reactions, which involves the ratios of reactants and products. By knowing the number of molecules in a given volume, it is possible to calculate the amount of substance moles present in that gas. Ideal gas law. Avogadro's hypothesis describes the behavior of gases under certain conditions. The ideal gas law relates the pressure, volume, temperature, and number of molecules of a gas. Atomic and molecular mass. Avogadro's hypothesis is used to determine the atomic and molecular masses of elements and compounds. By measuring the mass of a given volume of gas, and knowing the number of molecules, it is possible to calculate the mass of each individual molecule. Gas density. Avogadro's hypothesis is used to calculate the density of gases. By knowing the mass of a given volume of gas, and the number of molecules in that volume, it is possible to calculate the density. Gas mixtures. Avogadro's hypothesis is used to calculate the composition of gas mixtures. By knowing the number of molecules of each gas in a given volume, it is possible to calculate the proportion of each gas in the mixture. Reaction rates. Avogadro's hypothesis is used to calculate the rate of chemical reactions that involve gases. By knowing the number of molecules in a given volume of gas, and the rate at which those molecules react, it is possible to calculate the overall rate of the chemical reaction. Molecular collisions. Avogadro's hypothesis is used to study the behavior of molecules in gases. By knowing the number of molecules in a given volume of gas, and their average speed, it is possible to calculate the rate of molecular collisions, which is an important factor in many chemical and physical processes.